This presentation will focus on the relevance of quarries and material supply to design and construct mount breakwaters. Breakwaters always require large volumes of rock and quarry materials for the core, filter layers, and berms. Some breakwaters also need concrete for the armor and crown wall. The characteristics of quarries near the construction site, available rock sizes and unit prices, dollars per ton, are relevant when designing mount breakwaters. Having a quarry near the construction site is necessary to reduce economic costs and environmental impact. However, this is not always possible. Ground transportation costs depend on the distance from the quarries to the construction site, and sometimes maritime transportation is needed to reduce transportation cost. Rock sizes, volume of rocks, unique rock supply cost, and transportation cost to the construction site are key factors to be analyzed. If the Port Authority or developer owns a good quarry near the construction site, rock supply and ground transportation costs are very low, and rock supply reliability is very high. However, this optimum situation is not always the case. A monopoly of quarries near the construction site is usually a major source of uncertainty for the final economic cost of the breakwater. Here you can see the main breakwater of the outer port of A Coruña, Spain. In 2005, this coastline was a series of cliffs belonging to the Death Coast, with one of the roughest wave climate in the world. This huge breakwater, at 40-meter water depth, required tens of millions of cubic meters of rock. In this case, the quarry was excavated at the construction site. The quarry provided rocks for the breakwater and also ground space for the new port. For the main and secondary breakwaters, this quarry provided more than 25 million cubic meters of rocks and aggregates for more than 3 million cubic meters of concrete. In addition to rock sizes and total volume of quarry materials, we have to study the problem related to the placement and ground transportation on the breakwater. Large and long breakwaters may lead to congestion of trucks and ground equipment on the breakwater. We have to study the most efficient way to place the rocks using ground and maritime equipment in different parts of the breakwater. Efficient transportation may include an auxiliary way to load barges for maritime transportation of materials to build the deepest and most voluminous part of the breakwater. This is marked by broken green lines in this figure. Ground equipment to build the upper part of the breakwater. In the main breakwater of the outer port of A Coruña, barges transported rocks for 5-meter to 40-meter water depths. Ground equipment moved the rocks for 5-meter water depths to the breakwater crest, and concrete block for placement. To build a mount breakwater, one key factor is the quarry and material supply. Another factor is the congestion of ground equipment on the breakwater crest. These two factors will condition how we build the breakwater. The unit price of rock, dollars per ton, usually has a major impact on the final cost of the breakwater. Depending on the breakwater size, volumes, construction periods, congestion problems, and wave climate, it may be necessary to use barges for maritime transportation and to build up temporary winter groundheads. Thank you.